In the last video, we talked about the basic strategy of integration by parts. Namely, you want to pick u and v so that the integral of v du is much simpler than the integral of u dv. The trouble is, this strategy doesn't always work. Sometimes you get a situation where there's just no way to arrange it so that u dv is simpler than v du. But don't give up. Even when you can't make it simpler, there's a really cool trick for making it solvable. So our second strategy is, instead of picking u and v so that v du is simpler than u dv, pick u and v and u and dv so that v du is somehow related to u dv. Then we get an algebraic equation, and we use algebra to solve the resulting equation, and we figure out an integral. This sounds weird, but hold on, we're going to do an example. And this trick works really well for things like sine x cosine x, or sine x e to the x, or e to the x cosine x. Products of sines, cosines, and exponentials. It works wonderfully for those examples. So we'll do an example that's product of sine and sine squared. So in this example, we say, okay, how do you split up sine squared dx? Well, you could try making sine of x u and sine x dx dv. And let's do that. Let's see what happens. So we let u be sine of x, and dv is sine of x dx. And then the derivative of u is cos x dx. And the integral of dv is negative cosine of x. So, which is simpler? U dv, which is sine squared of x dx, or v du, which is minus cosine squared of x dx? The answer is, it's no simpler. You know, if you do the integration by parts, you get the integral of sine squared of x dx is u times v minus the integral of v du, so minus the integral of negative cosine squared. So that's the integral of cosine squared. And you look at that and say, what has this bought us? We started with an integral of sine squared, and we wound up with an integral of cosine squared, and that's no easier. But it's related. Cosine squared is 1 minus sine squared. So you split that up and you say, oh, well, that's the integral of minus sine of x cosine of x plus the integral of 1 dx minus the integral of sine squared of x dx. Now you notice you've got a integral of sine squared of x dx on the left-hand side, an integral of sine squared dx on the right-hand side. Now you use algebra. You add sine squared of x dx to both sides, and you get that twice the integral of sine squared of x dx is negative sine x cos x plus a constant. Then we divide by 2, and we get our answer. So the deal was not replace a hard integral with an easy integral. It was replace a hard integral with stuff minus the same hard integral. And then use algebra. If something is stuff minus itself, then twice that something is the stuff, and that something is half the stuff. Okay. Often, this requires 2 steps. So let's suppose that we want to integrate e to the x cosine of x dx. So you could actually go in either direction. You could pick your u to be e to the x or your u to be cosine of x. Doesn't much matter. We're going to pick u to be e to the x. And then dv is cosine of x dx. Then when you integrate that, you get sine of x. You differentiate e to the x, you get e to the x dx. So you have the integral of u dv is u times v minus the integral of v du. Okay, We've traded an e to the x cosine of x for an e to the x sine of x. So what? Well, let's keep going. Now let's try to integrate e to the x sine of x. And we're going to do the same thing. We're going to pick u to be e to the x. And let v be and then dv is sine of x dx. Integrate that, you get minus cosine. Differentiate that, you get e to the x dx. Okay. Put it together and you get all of that. So now let's combine our two equations. I'm going to call the first integral that I wanted I. I'm going to give it a name. Call it I. That was e to the x cosine x dx. And we said that that was e to the x sine of x minus the integral of e to the x sine of x dx. But minus the integral of e to the x sine of x dx is e to the x cosine of x minus the integral of e to the x cosine of x dx. Well, that's e to the x sine of x plus e to the x cosine of x minus I, and then you still need to stick in your arbitrary constant. Now we add I to both sides. We get 2I is e to the x sine x plus e to the x cosine x plus our constant. Divide by 2, and we win. So, if you can't replace a hard integral with an easy integral, try replacing a hard integral with a multiple of itself plus change, and then use algebra. One last thing about this process. I said that you could start off with making u e to the x, or you could have made u cosine of x. But whichever one you use, you got to keep going. If at this stage we had picked u equals sine of x and du equals e to the x dx, then the second step would have merely undone the first step. You want the second step to keep going. So if you differentiated e to the x the first time, you want to differentiate e to the x the second time. You integrated cosine the first time to get sine, so you integrate sine the second time to get minus cosine.